Hello there! In this tutorial, we are going to be creating the basic logic for Mario-style platformer in Pygame. And this project is eventually going to look like this, although that is still quite a far way off. Although, by the end of this video, you should already be halfway there. So let me go over what I am going to cover in this video. First of all, I'm going to talk about how to set up this kind of level. That's the easiest part. Then after that, I'll talk about how to move this entire level left and right, so we can simulate a camera. After that is covered, I'm going to insert a player, so that we can connect the player movement with the level movement, so we have a camera following the player. After we have covered that, we are going to take care of the player movement. So at this stage, we are going to add collisions, jumping, and all of that stuff. And by the end of that, we already have a basic logic for a platformer, although arguably not a great one. But then in the second half of this video, we are going to work on the player character. So in here, we are going to cover quite a few different things. The most important one is the animation states of the player. So we are going to figure out what animations we have to play given what circumstances. So for example, is the player on the ground? Is he running? Is he idling? Is he colliding with a wall? Is he falling? Is he landing? All of these information we need to play the right animation. And then along with that, obviously, we also have to cover basic animations for the player. And those two steps are very much connected, so I'll cover them in one bit. And then finally, I have added some particle effects, so that when the player is running, jumping, or landing, we show a bit of dust at the bottom of the player, which I think makes the game look much better. And that, well, is going to be the entire video. I believe it's going to be slightly longer. But it is going to give you all the tools to start creating a proper platformer. And do get subscribed so you don't miss out on the future parts in the series and you can make the whole platformer. So with that, let's start setting up this level. And here we need two bits. First of all, we need some kind of layout that we want to follow. So think of that we want to create a level, but we need some kind of map that tells us where stuff has to be. And in my case, I just used a string that looks like this. And all I am really going to do is to cycle through this string and get the row and the column of each element. And then I use that information to place something on the screen. You'll see in a second how that's going to look. And the code to place something like this looks like this. And this is the very same logic I have used in another tutorial of mine in Space Invaders, where I have used the very same logic to place the aliens and the obstacles. So this is very much transferable knowledge. And I think it's best to explain this while I actually set it up. So let's jump into our code and let's have a look at this. Here you can see the most basic setup for Pygame. And if you have followed along my tutorials, this should be quite obvious at this point. So if I run this code, all we see is a black window with the screen dimensions of 1280 by 700. And you can't see anything because we're not drawing anything yet. Now, if you have no idea what this code does or what any of this means, check out my introduction to Pygame. That should be really helpful. But alright, so the first thing I want to do is to create some kind of map so we know where the player is going to be. And since I want to keep my code organized, I'm going to put all of this in a new file. So I'm going to create a new file and I'm going to save this as, let's call it settings.py. And this is going to be in the same file as my main file, which is the file you have just seen. So now we have two Python files, one called main and one called settings. And in settings, I want to create a string. And for me, this looks like this. And this is going to be our level map. So let me explain how this is going to work. Generally, this thing is a list. So we have opening brackets here and closing brackets here. And then inside of this list, we have a couple of strings. So we have string 0, we have string 1, we have string 2, we have string 3, and so on. I think in total there are 11 or 10 strings in there. Let's say it's 10 for simplicity. And each of these strings would effectively going to be my row. So the top row would be number 0, so this would be the row at the top of our game. And then inside of each string, we have a couple of characters. We either have a space, like this one for example, or we have a capital X, like this one for example. And each of these characters is going to be one column. So if I go with this row here, this would be column number 0, this would be column 1, 2, 3, 4, and so on. And if I combine these two bits of information, I can tell very well where a certain element is going to be. For example, if I look at the X in the bottom left here, I know this is going to have the row 10 and it is going to have the column 0. So I know exactly where it is going to be. And that is the information I can then use to place something on the screen. So this is going to be super useful. Now, along with that, I also want to specify a couple more bits of information. The first one is my tile size. And this one I've set for 64 pixels, which I think is a pretty good size. And now, along with that, I also want to put my screen size and my screen width in here. And you're going to see later on why this is important. Essentially, we are going to import this settings file into lots of different parts of our code. So having access to the screen width and screen height everywhere makes our life quite a bit easier. And as a matter of fact, we are going to make some changes here. Now the screen width, I'm going to leave as it is. If you have a smaller screen, it's perfectly fine to make this number smaller. We're going to keep the rest of the game responsive to it. So make this as large or as small as you want, whatever fits your screen. However, now for the screen height, I want this to be relative to this level map here, so that this thing informs how tall our screen is going to be. So effectively what I want to do, I want to multiply the number of rows by the tile size. So let me put this in there. And that will be always fit the level on our screen, which is going to look quite good, I think. And this could actually be a really good exercise for you, that I want you guys to change the value of screen height so that it is influenced by the level map multiplied by the tile size. The first bit of information I have to know is how many elements are inside of this list, because each element is one row. And for that, I am going to need the len method. And I want to get my level map. But this right now would be a number like 10 or 11. And I don't want my screen height to be 10 pixels high. So I want to multiply all of this by tile size. And now I could print my screen height, and let's run this. And we get 704. And if I just print my level map, I get 11. So in this thing, we have 11 rows, starting from 0 and going all the way to 10. So all right, we don't need that anymore. And now we have a basic setup for our game. And this we are going to use in quite a few parts of our game. So now I can go back to my main Py file. And the first thing I have to do is to import all of this. So from settings, import star. So we import all of the stuff we have created in here and we can use it. So that way we can leave screen width and screen height as they are. So now let's try this. And we still get the same black screen, although the height slightly changed by a few pixels, but that really doesn't matter too much. So now this map is telling us where stuff has to be. And now to turn this thing into something we can actually see in Pygame, we will need two things. First of all is some kind of block that we can place somewhere on the screen. And this is going to be a sprite in my case. And then the second part is a function that goes through each of these elements and plays something on the screen wherever we find a capital X. And well, let me go back to my main file. The first one we are going to need is then our sprite. And I put this in a new file. Let me save this, and I have called this tiles. And in here, I want to import Pygame, and then I want to create a class I call tile. And this one has to inherit from pygame.sprite.sprite. And again, if you have no idea what the sprite is, check out my beginner's tutorial to Pygame that explains all of this in much more detail. But in here, I want to create an init file that needs self, and now I want to specify two more bits of information. The first one is the position, and the second one is the size. So we can tell where each tile is and how large each tile is going to be. And now in there, I want to create my super.init method. And then besides that, I want to create self.image, and I want to create self.rect. And now we have to figure out what information to put in here. And this again could be a really good exercise. That I want you guys to just create a plain rectangle using this tile. So this tile should have the width and the height of the size and the position of, well, the position. So let's get started. First of all, for my image, I just want pygame.surface. And here I want size and size for X and Y. So the first size is going to be X, and the second size is going to be Y. And since I'm creating a square, those have to be identical. So this is already what I needed. And now for the rectangle, I want to get self.image.getRect, and I want to place the top left wherever my position happens to be. And now this way, I can place this rectangle wherever the position is, and it's going to be the size of my size. And there's one more thing that I will need, because right now this tile is going to be black. So I want to get my self.image and fill it with a color. And I went with gray, but you can place any color you want in here. It really does not matter. So with that, we have the first part, that we have a tile we can place somewhere on the screen. And let's actually try this. So back in my main file, I want from tiles import tile. And first of all, I have to create a sprite group. So let's call this test tile. And this is going to be pygame.sprite.group. And in here, I want to get my tile, and I want to place it at position 100 and 100. And those two have to be a tuple. And then for my size, I want 200. And now in our game, I can get my test tile.draw on the screen. And if I run this, we can see our tile. So we know this class is going to work. Although obviously we don't just want to place them randomly on the screen, we want to place them in a specific position. So I'm going to get rid of this and this, because I don't want to create a tile in my main file. As a matter of fact, I want to create another new Python file, and this one I'm going to call level.py. So now we have 4 different files. We have our main file, we have a level, we have tiles, and we have settings. And all that's really going to happen is that in our level file, we create a class called level. And this level is going to rely on tiles to place something on the screen. And then in our main file, we are only going to create one instance of this level and then draw it. And that way we keep our entire setup nice and clean. But alright, let's actually start importing stuff. So first of all, I need import Pygame. Second of all, I need to have access to this tile here. So from tiles, import tile. And once I have those 2 pieces of information, I want to create my class level. There's no inheritance, but we do need a thunder init method. And in here, besides self, I want 2 pieces of information. First of all is level data. So right now, my level data would be this level map. But I want to be able to pass different level maps into this level to create different level setups. And then second of all, I need a surface. So the surface I want to draw on. And well, with that, I can define a couple of attributes. The most important one is I want to have an attribute called display surface. And this one is just going to be surface. And for now, let me also create self.level data, and this is going to be just level data. And now in my main file, I want to import this level. So from level, import level. What I'm going to do is, let's call it level in here as well. And this is going to get level itself. And the 2 arguments I have to pass in here is my level, I think I called it level map. Level map, yeah. And then besides that, I want to have my screen in there. So this is the display surface we want to have for this surface. And with that, in our main file, we have access to the level. And now all I really want to do in this main file is to run something like level.run or level.draw. And that way we are going to keep all of our game logic inside of the level, which I think makes sense. Now obviously right now this level doesn't have a run method, so we have to give it one. So self.run, and for now we don't really have anything to do in here, so I'm just going to add pass. But there's going to be a lot of stuff in here later on. So alright, with that we have our basic level setup. Now I want to create a function that cycles through all of this and places a tile wherever we find a capital X. And this is going to be in another method. And I have called this setup level. And I want to have one argument in here besides self, and that is going to be the layout, which is going to be this level data. And I don't actually have to store level data in its own separate attribute. Instead, all I want to do is when we run the init method, I want to get my self.setupLevel and pass in the level data. So now we have to figure out what to do inside of this setup level. And the first thing we have to do is to create a sprite group. And I have called this one self.tiles. This one is just going to be pygame.sprite.group. So we know what group to work on. And this is actually something we can already do in our run method. That I want to get self.tiles.draw and then self.displaySurface. So whatever we place inside of these tiles, we are going to draw in our run method. And now we have to figure out how to get the row and the column of each of these items here. And this is just going to be a for loop, although it's a slightly more complex one. So let me build this one up slowly. First of all, I want to loop over every single row. So for row in layout. And in here, all I want to do is to print the row. And let's actually see what this is going to do. So in my main file, I'm going to run this. And what I can see, let me close this, is down here in the console, we can see our level. So this is looking identical to what we have here. Because literally all we are doing is we're printing every single line. So that's a pretty good start. But there's one downside here, that we don't know on what row we are on. We just know the row itself, but not where that row is. So I want to know what index this row is on. And for that, we need the enumerate method. And what enumerate does is it gives us an index and the information. So I have to add in here, let's call it the row index. And what I can do now, let me duplicate this, and I want to get the row and the row index. And now in our main file, let's run all of this again. And now get the information. On row 0, we have nothing because on this row, there literally is no capital X. The same for row 1 and for row 2. So all of this here is completely empty. However, on the next row, we have a couple of X's. So we know on the third row, we have a couple of X's here, and we can still see those. So this way, this line here tells us what row we have and where that row is going to be, which is super important information. Now, next up, I have to figure out each column, and this is going to be another for loop. And this for loop is going to look very similar. So I can just copy this entire line, and instead now I want to get my column index, and you could either call this column, I'd like to call it cell. It really doesn't matter. And I want to loop over the row. So for each row we are getting, I am cycling over every single item inside of that row, which is going to be each individual character inside of that string. And since I'm still getting the index, I know exactly where stuff is going to be. So in here, for example, I could print, let's call an F string with the row index, then another one with the col index, and then let's say double colon, and then I want to have another variable with the cell. And let's put a comma in between there. And now if I run this, I can see each individual cell. So I know on 0 and 0, we have nothing. However, at some point, there we can see some. So here we have a couple of X's. So I know in row 4, column 1, we have 1X, which is going to be this X here. So this X down here is going to be this X up here. And now we know exactly where this X has to be at position 4 and 1. So this is then exactly what we are going to need. So, all right, this is already working really well. And now in here, I want to add an if statement that if my cell is equal to the value of X, because we only want to place something if there is an X. And now if that is the case, I want to place a tile. And this tile is just going to be our tile class. And in here, we need 2 arguments. First of all, we need the position, and then we need the size. Now the size we already have, because in our settings, we have a tile size. So I want to use that, so tile size. But to get that, we have to import it into this Python file. So from settings, import tile size. And now we have to figure out the position. And for now, let's just go with X and Y. And be aware here, this has to be a tuple. Don't forget that. And now that I have a tile, I want to get my self.tiles and add this tile to it. And well, this should already be a pretty good start. So back in my main file, let me see how this is going to look. And we are getting an error because, let me close this. Oh yeah, right. And the reason for it is we don't have X and Y yet. So let's create them actually. So I want to have an X and a Y. And this could actually again be a really good exercise for you. I want you guys to figure out what numbers have to go in X and Y to place each tile properly. So let me start with X. And in here, I want to have my column index because this is the one that goes left and right. And for Y, I want to have my row index because I want to go up and down. And now this would be a starting point. But if I run this now, we can actually see it. And you can see in the top left a couple of gray squares. Now, the problem is they are all overlapping with each other. Because effectively, all that we are going to do, and let me actually make this a bit smaller. All we are going to do here is we get the index of the row or the column. So for example, the row would start at 0 and go all the way to 10. So when we place this Y inside here, this is going to be a number between 0 and 10. So it's way too small. And the same applies to X. So instead, what I want to do is to multiply this by the tile size. And this I want to do for both of them. So tile size for both. And now let's try this again. And there we have our level. So this one is looking really nice. And let me just explain what happens here. So if I go to my settings file, and let's look at this row here. So this row. We know that this row is on 0, 1, 2, and 3. And then the first X on this row is at position 1. So this X is going to have the column of 1, and for Y is going to have the row of 3. So right now, this would just be pixels that we are placing. But if we multiply this by 64, so our tile size, so 64 for both, we are going to place it just to the right of the previous block, which would have been 64 pixels wide as well. Now in this case, there is no block to the left of this X, but if there were, this one would be right to the right of it. And this way, we can use this logic to place the entire map. So I hope the logic here makes sense. And also, if I run this again, we can tell that our window doesn't cover the entirety of our level. So what we have to figure out is how to scroll in this map. And the logic here is actually amazingly simple, because all I want to do is move all of these sprites either left or right by a certain amount. So what I have to do in my tile, I want to give this one an update method. And this one is going to need self, and let's call it X shift. So by how much I want to shift this tile. And really, all we have to do is get self.rect.x and add plus equal X shift. And now back in my level file, when I run all of this, I want to get my self.tiles.update. And now I have to add one argument in here. And by default, this is going to be 0. So if I have 0 in here, I run this, you cannot see any difference. However, now, if I placed a 1 in here and run all of this again, now this entire thing is going to move. And if I placed a -4 in here, for example, we'll move in the other way. And that way we can scroll through our level. And later on, once we have a player, all we really are going to do is to change this number here. And since we want to influence it, I want to put this into an attribute. So let me place it here, and let's call it self.world shift. And by default, it's going to be 0. And this then is going to be the argument in here. And let me get rid of this. And let's add some comments in here to make this a bit clearer. And let's call it level setup. And now I can minimize this. And with that, we have covered the very first part of this video. So now we have a level that we can scroll through. Obviously, it doesn't help us particularly much yet because we want to add a player to all of this. And well, for that, we have to add a player. And for now, just to get started, this player will only be able to move left and right. And once we have that, we can talk about how to connect the player to the level scrolling, so we have a proper camera. But, well, the player is not going to be anything complicated. It is also going to be a simple sprite class that we can move around. So let's actually create it. Here I'm back in my main file, and what I want to do is to create a new file. And I'm going to save this one and call it player.py. And in here, I want to import Pygame as always and create a class that I call player. And this one has to inherit from pygame.sprite.sprite. And spelling this correctly would also help. And in here, I want an init method that needs self and nothing else for now. And then in there, I want to get super.init so we don't get an error. And now in here, again, we need self.image and self.rect. Now for the image, since we are going to change this later on anyway with proper graphics, what we put in here doesn't really matter. So I'm just going to add a plain surface that is 32 pixels wide and 64 pixels high. And then self.image.fill so we can actually see it. And I'm going to fill this one with, let's say, red. And now for the rectangle, I want to get my self.image.getRect. And I want to place the top left where we have a position. And this position we are going to get in the init method. So now we have a player class, and the next step is we have to place this inside of our level. And as a matter of fact, I want to get this position from this file here. So I want to have the ability to add one additional character in here. Let's place the character in this position here, and let's call it P for player character. Actually, let me put it a bit further to the left so we can see it when we run the level. So let's say here, I want to have my player. And then when we are running this setup level, I want to place not just my X, but also my player. And this could be a really good exercise for you. That I want you guys to figure out how to add a bit more code in here to place our player along with the tiles. So pause the video now and try to figure this out yourself. The first thing I am going to need is another sprite group, and let's call this self.player. And this is going to be pygame.sprite.group single, because we only want to have a single player. And now in this nested for loop, I want to get if cell is equal to a capital P. And if that is the case, I just want to copy all of this, because the X and the Y stay exactly the same. But now, instead of tile, I want to create a player. And let me also call this one player sprite. And our player is only going to need an X and a Y coordinate. And right now, I don't have player imported, so I have to do that as well. So from player import player. And then I want to get my self.player group and add my player sprite. So this should then all be needed to place our player. Now, what you could be doing is get this code and place it right before the if statement. That might actually be a bit cleaner. This might be a slightly better code. So now we always get the X and the Y coordinate, and then we use a capital X or capital P to check if we actually need it. Both approaches would be fine. You could also do this inside of the if statement. It really doesn't matter all that much. And now with that, we have our player in a certain position. However, we wouldn't be able to see it because we're not drawing the player. So I want to get self.player.draw and self.display surface. And since we're going to add quite a bit to this level, I'm going to add some comments. So this is going to be the level tiles, and this is going to be the player. And now back in my main file, let's try this. And there we go. We can see our player exactly in the position where we placed it. So this is really good. And with that, we can open my player and give it the ability to move. And this is just going to be another method. So let's call this get input. It doesn't need any arguments. And in here, I want to get all the keys we are potentially pressing. And this happens with pygame.key.get pressed. And now in there, if keys is pygame.key, let's start with right. Then I want to move the player to the right. And for now, let's add a pass in here. If that is not the case, so elif, and I have keys for pygame.k left, then I want to move the player to the left. And if neither of those are the case, so else, then I don't want to do anything. So now we have to figure out 3 different lines of code to make our player move. And in my case, I have used a vector. And vectors I haven't talked about yet, but they are ultimately very simple. So let me create one and then I'll explain it. First of all, as an attribute, I want to get self.direction. And this is going to be pygame.math.vector2. And this one is going to need 2 arguments. And they're going to be 0 and 0. So let me explain what vectors are and how we can use them in Pygame. If you have gotten through high school, you probably have seen vectors already. They are essentially just arrows you can draw on a coordinate system. So for example, if you have a vector with 150, it would be an arrow that looks something like this. And all that really means is that we are moving 100 pixels on the x-axis and 50 pixels on the y-axis. And then we are connecting the start point and the end point. And that way we have an arrow. So all the vector really is a list with an x and a y value. That's literally it. And this is going to give us a couple of useful features in Pygame that we can use. The most notable one is that when we have a rectangle, we can just add our vector to it. So we don't have to worry about x or y. And this is going to make our movement significantly easier and cleaner, because we don't have to worry about 2 different variables for the movement. It can all be in one neat variable. They do have quite a bit more functionality, but I'm not going to use that. So, all right, with that, let's go back into the code. And in here, I now want to change my self.direction if we are pressing right. So I want to get my self.direction, and in here, I can either target X or I can target Y. And obviously, X is the horizontal one. So this, I just want to be 1 for now. And then if we are pressing left, I want to do the exact opposite. So -1. And then if we're not pressing either of these buttons, I want this to be 0. So we're not moving at all. And now what we can do, I can define an update method like we have done for the tiles. And now inside of this update method, I can get my self.rect. And for now, I just want to move horizontally. So X and then plus equal self.direction.x. And of course, don't forget to call self.getInput, because we do want to call this function as well. And as a matter of fact, in my level class, I also have to update my self.player. So self.player.update, just like we have done for the tiles, although the update for the player doesn't need any arguments. So now, if I go back to my main file and run all of this, nothing happens by default. But if I now press right, we get a rightward movement, and the same for left. So this is already working very well. But now we have a problem that our player is really slow. So that's not great. And fortunately, that can be fixed very easily, because what we can do is to multiply this vector with a number. And let's say in my case, I think I went with 8. And now if I run this, we get a much more appropriate movement. So this is working really well. And this speed, I want to call self.speed, because this we are going to influence later on. So self.speed is just going to be 8. So if I run off this now, this works just as before. And now with that, we can start thinking about how to connect this player to the actual level. So right now, if I move outside of the screen, well, the level doesn't move along with it. So let's talk about how to create the camera that scrolls the level when the player is moving too far to the left or too far to the right. And the first thing you have to understand here is that we have a limitation. That in Pygame, we can only draw on the window and we can't move the window by itself. This is always fixed. So let me explain what we are going to do instead. And let's do this by an example. Let's say our player wants to move to the right and we want to scroll the level along with that. So essentially what we are going to do, if the player reaches a certain point on our window, we are going to set our player speed to 0, so the player cannot move anymore. However, at the same time, we are going to move the entire level to the right by the speed of the player. So that way it seems like the player is moving at the same speed, but in reality, the player itself is not moving. Instead, the entire level is moving at the same speed in the opposite direction. So to the person playing the game, it looks identical, but the player doesn't actually move. And then we can apply the same logic to the left of the screen, and then we have our level scroll. And that's all the logic you need to implement this. So let's jump into our code and let's have a look at this. So here I'm back in my main file, and I want to go to my level, and I can minimize all the methods here. And I want to create a new method that I call scroll x. And this one only needs one argument, and that is self. And in here, I want to create a couple of variables first, although it's not strictly necessary. So let me explain it. First of all, I want to get my player. And this is just going to be self.player.sprite. Then I want to have my player x, and this is going to be player.rect.centerx. So we're just taking this player here and getting the center of the x position. And then finally, I want to get my direction x, and that is going to be player.direction.x. So with this information, I know my player, I know where my player is on the x coordinate, and I also know in what direction my player is going to move in. And this is going to help me keep my code a bit more clean. And you don't necessarily have to do this, but we are going to use a couple of if statements. And if you always had to type the entire line here, it would get quite long and a bit hard to read. So this is making things slightly easier. So, all right, let's start with the left side of the screen. So I want to check if my player x, so the x position of my player, is, let's say for now, let's say 200. And if that is the case, I want to set self.world_shift to 8. And then my player.speed to 0. And now if I run this function, let's place it right below the player. I think that makes sense there. So self.scrollx. And now let's see what happens if I run this code. So now I move to the left, and you can see we have a scrolling. Although it never stops, so it doesn't help us too much yet, but it is a start. So I can minimize our run function. We don't need it anymore. And now in here, we have to add a couple more things. First of all, I want an elif statement that if my player x is greater than, let's say, 1000 for now. If that is the case, I want self.world_shift to be -8. And again, I want to set my player speed to 0. And if neither of those things are the case, I want to set self.world_shift back to 0, and my player speed should be 8. And now let's try all of this again. It is almost going to work. So now we are still moving all the way to the left. And the problem here is that once we are reaching this point, let's say our player is at position 199. If that's the case, our level is going to move and our player cannot move anymore, so we're always stuck in this position and the level scrolls forever. The same if we were moving to the right. So we can never really reach this else statement once we ever reach this or this if statement. So I want to add another if condition. So I only want to move to the left if the player is in this x position and if our direction.x is below 0, which means that we are moving to the left. I want to do the opposite for the right side of the screen, so greater than 0. And now let's try this again. Now I can almost make this work. So I can stop the movement now, but I cannot go back to the right. And the reason for that is that I made a mistake, that this should be player.speed. And now let's try this again. So now I can move around and the level scrolls along with my player. So that way we have a proper movement and this is working quite well. Cool. Now there's one more change I do want to make. That right now these numbers here are constants. So if our game window became larger or smaller, they wouldn't update along with it. So I want to make those responsive. And this could be a really good exercise for you. That I want you guys to add some code to make these two numbers responsive to the size of the window. Okay, I hope you managed. Now, the first thing we are going to need is the actual width of our game window. So in our settings file, this screen.width. So I have to import it. So screen width from our settings. And really, all I want to do here is screen width divided by 4. So in my game, this would be the coordinate of 300 or 1200 divided by 4. And now I want to do the same thing for the other condition of the right side of the screen. And all I want to do here is to get my screen width again and just from that subtract the same number. And let me put it in brackets to make it a bit clearer. So this way we get our entire screen width and subtract 1/4 of that width. You could also get screen width multiplied by 3/4, really the same thing. And that, if I run all of this again, it's still working and this is looking really good. So now we could make the game wider or smaller, it would still work with the scrolling. At least I think it does. So alrighty, with that we have our basic level setup, we have a player and we have some basic scrolling mechanic. So that's a really good start. Now next up, we have to start talking about how to make the player jump and move around more freely in this. And this is going to be a larger section. However, before addressing the collision, I would really like to add some gravity and the jump mechanic to our player. And that way we can move around freely on the level and then we cover collisions. That should make a bit more sense. So for our player, let's add some gravity and let's add some jump mechanics. And this should be some of the easier parts. So I think we can jump straight into the code and let's have a look at this. Here I am back in my main file and I want to look at my player. And in there, I want to create a new section. And let's call this player movement, so we keep the code a bit organized. And besides the speed, I think the direction should also be in there. And I want to add 2 more variables in here. The first one is going to be self.gravity. And I have set this to 0.8. And then besides that, I want to have something like jump speed or jump height. And this one should be a negative number, and I've put this to -16. And it's negative because I want the player to jump up. So with that, we have all the basic variables that we are going to need. And now that we have these variables, I can add a method to apply the gravity. And let's call it apply gravity. It doesn't need any arguments besides self. And all I want to do in here is get my self.direction.y and add plus equals self.gravity. So that way our gravity is going to be increasing on every single frame. And this number I also want to apply to my self.rect.y. So plus equals self.direction.y. And now in my update method, I can just call self.applyGravity. And we should be having gravity. Let's try. And we are indeed falling down. So this is working quite well. But obviously our player disappears immediately. So this by itself isn't great because we can't counteract it. So for that, I want to create a jump method. And for this one, all I want to do is get my self.direction.y and set this to my self.jumpSpeed. And then this I want to call whenever I press the space button. And this could actually be a really good exercise for you. that I want you guys to add some code to only call this function when the player presses space, or whatever key you feel is appropriate for jump. It doesn't really matter. So to get the jump button, in my case, I need my getInput method, and I have to add another if statement, that if keys pygame.k space is the case, so we're pressing the space button, then I want to call myself.jump. And that should be all we needed. So let's try this now. And we have indeed a jump mechanic. And our level scroll is still working just fine. So this is looking quite good. So now we have a basic player movement. And this works as intended, but it's not great because we don't have any collisions. And that we can start working on now. Because the logic here gets very simple once you understand it, but if you don't understand it, it's going to be a nightmare. So let's talk about collisions in 2D platformers. And if you ever try to make a platformer yourself, you probably already know what the problem is. That Pygame can detect when a collision occurs very reliably. However, it cannot tell you where that collision occurred. So for example, if you have a player colliding with the top right of a tile, you know there's a collision, but you don't really know if this was on the top or on the right or on both, and it's really difficult to work with this. And unless you know how to work around this problem, you will continuously end up with a problem where you collide with something on the left, and then Pygame puts your player on the top of a block that you collided with, which would obviously break any kind of game. So the major problem here is how to separate the X and the Y dimension of our movement. And well, the obvious solution is that you have to separate your vertical and horizontal movement. And I know that sounds a bit silly, but really all you have to do is to first apply all the vertical movement, then apply vertical collisions, then you apply the horizontal movement, and then you apply the horizontal collisions. And that way you can very reliably figure out which block you're colliding with. And to really emphasize this, I'm going to create two methods. The first one is going to be for the vertical movement and collision, and the second one is for the horizontal movement and collision. And that is going to make it explicit what we are going to work with. And I guess another minor point is that this movement is going to happen in our level class, not inside of our player. And the only reason for that is that it's much easier to get all the collisions inside of our level. So with that, let's actually jump into this and let's see how far we get. So here I am back in my player class and I want to open my level.py. And let me minimize all this stuff in here. We are not going to need any of this. And first thing I want to do is to create another method that I'm going to call horizontal movement collision. And we don't need any arguments. And in here, we have to do a couple of different things. Now, first of all, I'm going to target my player character a lot. So just like for the scroll method, I'm going to get self.player.sprite. And this is going to save me quite a bit of typing later on. Now, the first thing I want to do is to actually apply the horizontal movement. And for now, we have done this inside of our player class. But I want to take this out of here and do this inside of the level class. And now we have to make a couple of changes. So all the self should just be player. And let's actually put all of this inside of our run method as well. Let's put it right below player update. And I think scroll X should actually be in there as well. Actually, I think scroll X should be in the level tiles and then the player gets all of this. So self.horizontal movement collision. And that feels like a better setup. And let's try if all of this actually still works. So let me run the main file. And I can still move around, even though our movement happens now inside of the level class. But cool, this is still working. And now with that, I can actually look at the collisions. So I want to cycle through all of the tiles I could potentially collide with. So for sprite, in self.tiles, I think I called it. Let's double check. Yep, self.tiles. and .sprites to actually get all of the sprites. And now I want to check if sprite.rect.collide.rect with my player.rect. So we are going to use the collide.rect function. And you might be asking yourself, why are we not going to use the sprite collisions? And the reason for that is that I want to have access to the rectangle of each of the tiles. And if we use sprite collide, this would be quite a bit more difficult. Not impossible, but a bit less convenient, I would say. And this one is still perfectly fine. So now we know if the player is colliding with one of the tiles, or one of the rectangles inside of the tiles. And now I have to figure out if this is on the left or on the right side of the player. And the easiest way to figure that one out is to just look at the direction of the player. So if our player is moving left and we have a collision, we are probably colliding with something on our left, and then the same for the right side. And that way, all we need is a single if statement that if my player.direction.x is, let's say, smaller than 0, which means we are moving left, then I want to target my player.rect.left and put it in sprite.rect.right. And if that is not the case, so elif player.direction.x is greater than 0, then I want to do the exact opposite. So player.rect.right is equal to sprite.rect.left. And let me go over what's happening here. Here we have the first part, and we are just applying the horizontal movement. This one is super easy. Once we have that, we are looking through all of the sprites, and we check if we have a rect collision. And then we check if our rectangles collide. So if we have a player and one of the tiles, if they are colliding. Now, if that is the case, we are checking if our player is moving left or moving right. And if these two conditions work, so if we have a collision and a movement, let's say for this case here, then we know the collision is going to happen on the left side of the player. So then we can move the player exactly on the right side of the obstacle it collided with. And that way we, well, place the character in the exact right spot. And that, for the most basic logic, was all we needed. So let's actually try this. So there you can kind of see it, and let me go to this side. So there you can see that if I have this wall, I cannot go further to the right. Now obviously, if I jump on top of something, we get some very weird behavior because, well, we don't have a vertical collision yet. But the horizontal one works just fine. So with this one method, we have covered our horizontal movements and collisions. And now all we have to do is do the same thing for the vertical movement and collision. And this, I think, is going to be a really good exercise for you. That I want you to try to understand this entire method and copy it for the vertical movement and see how far you get. And the vertical one is going to be slightly different because we have gravity. But it's not all that different, so I'm confident you can do it. Alright, so let's try together now. First of all, I need to create the method itself. So vertical movement collision. I am not entirely sure if this is a good name or not. I am awful with variable naming. But alright, so first of all, again, I want to get my player itself to save me some writing. And first of all, we have to apply the vertical movement. And for that, I want to get my player. And now I want to apply gravity, not in the player itself, but instead in this vertical movement. And so I have to change self to player. And now we are calling jump inside of the player. And this is still working just fine, so we can leave it in here. That's the one exception. And now that we have covered that, I can just copy this entire block of code and paste it in here. And the only change I now have to make is to change this X to a Y. And for this one, let me start with the downward movement first. That's, I think, the most common one. It should be on top of the if statement. And if that is the case, I want to get the bottom of my player and set it to sprite.rect.top. And then the other case, if we are moving upwards, I want to get the top of my player and set it to the bottom of whatever we are colliding with. And well, now all we have to do is to call self.vertical movement collision, and let's see if this is working. And now if I run all of this, this seems to be working. However, if I now stand for a bit, at some point our player is going to disappear. And the reason for that is quite obvious, I think. That whenever we call apply gravity, we are increasing the gravity. And we never stop doing that unless we jump. So if we just keep on standing on the ground, the gravity is going to increase more and more. And at some point it's so large that the movement would jump right over all of the tiles. And that way it would fall apart. But that fortunately is a very easy problem to overcome. That in this line here, when we check if our player is standing on top of the tile, if that is the case, I want to get my player.direction.y and set this to 0. And this way, after we are increasing the gravity and we have hit a bottom tile, then we set the direction y to 0. So the gravity is cancelled out. And now let's try this again. This should work much better. And now we have collisions that work pretty good. And also works for the top. There's another problem. So here you can see if we hit a top ceiling, we kind of don't fall down immediately. And the reason for that, if I go back to level, is that if we hit this if statement here, we have hit a ceiling, but our direction.y is still negative. So it keeps on increasing, but it's always being placed in this position again. So it doesn't go any higher, but it also doesn't go downwards again. And well, to fix that part, all we have to do is to call the same line we did for the bottom. So this way we are cancelling out any negative y direction movement we have. And now let's try this. And I can jump around. This still works fine. And now if I hit the ceiling, I go down immediately again. And well, with that, we have a basic 2D movement. And this is actually working really well. Okay, except I am terrible at playing video games. So with these two methods, you should be having a pretty good vertical movement. And that is also finishing up the first part of this tutorial. So now we have our basic 2D movement. However, there are quite a few more things that we have to do. And we have to do all of those for one reason. That when we animate our player, we have to know quite a few bits of information. For example, we have to know if the player is moving against the left or right wall. We have to know if the player is on the ground or against the ceiling. We also need to know if the player is looking left or right. And later on for the particle effects, I also want to know when the player is jumping and when the player has landed. And there are lots of different pieces of information that we need to make this work. And this is still very much connected to the collision detection in our 2D level. Which is why I've put those two parts into one tutorial, because they are very tightly linked to each other. However, for the player animation, there's one major problem we first have to address. And that is that we have to work with quite a few different images. I think it's about 20 in total. So for example, the run animation has 6 frames by itself. And this is somewhat similar for all the other animations as well. So before we can talk about the animation, we first have to figure out how to import all of this and how to store it efficiently in Pygame. And in my case, there are 2 key things you have to understand for this tutorial. Number 1 is that I have stored all of the animations inside of a dictionary. So each key is the style of animation, and then the value is a list with the individual images. And each image is already on a surface. And that way we can access the different animations quite easily. Now for part number 2, I have used another module to import all of these images. And that module is called OS, and this gives you quite a few useful features. And I'm going to explain that when we actually use it. But before that, let's go through this step by step, and let's start with step number 1. That I want to create a dictionary with all the animations that the player is going to have. So here I'm back in the code, and I want to get to my player. And let me minimize all of the methods, it's not that many. And in here, let me put it right below the init method. I want to create another method, and let's call this one import character assets. Doesn't need any arguments. And now we need a few bits of information. The first one is, I call this character path. And this is just a path to the folder where all the folders with the different frames are in. And this is just going to be a string. So we go one folder up, then we go to a folder called graphics, and then there's a folder called character. And then I want another slash, because inside of that folder, there are a couple more folders that each hold a couple of animation frames. And I want to target each of these folders. Now, next up, I actually want to create my dictionary, and I call this one animations. And this is going to be a dictionary. And in here, I just want to create a couple of lists. So my first animation is idle, and this is just for now going to be an empty list. Then the second one I called run, and they're all going to be empty lists. The third one is going to be jump, also an empty list. And then finally we have fall. And well, that is all we needed. And now a really important thing to consider here is that the name of the animation is the exact same as the folder inside of this folder. So we have a folder for idle, a folder for run, a folder for jump, and a folder for fall. And that is incredibly important because we are using those names to access this folder. So make sure to name them appropriately. And well, let's actually work on this right now. So I want to cycle for animation in self.animations.keys. And from that information, I want to get a full path. And the full path is just going to be my character path plus the animation. So really, all I'm going to do, let me draw this actually, is that this character path here is just this line here. And this animation is one of these 4 animations. And literally all I'm going to do is I'm going to attach this right at the end. And that way we get to access the files inside of one folder. That's literally all that's happening here. And now all I want to do is to target my animations folder and then get the animation I want to work on. So now we can target one of these 4 items. And now what I want to do is use this path here to import all of the images that are inside of this folder. And this is a function I have called import folder. And it only takes a single argument, and that's the full path. So now we have to create this function here. And I have put that one in its own file. So let me create a new one. And I've called this one support.py. And in here, I want to create define import folder. And it needs a path and nothing else. And now back in my player, I want to from support import folder so we can actually use it. So now we have to figure out how we can actually import all of the images inside of a folder. And for that, we come to the part I talked about earlier, that we use a specific module that Python has available that can be super useful. And that module is called OS. OS gives you access to lots of system functionalities. And one of those is to go through your file system. And the specific method for that is called walk. So I don't want to import all of OS. Instead, I want to go from OS, import walk. So let's talk about how to use walk. Essentially, you are always going to use walk inside of a for loop, because walk is going to return 3 different things. It returns the directory path, the directory name, and the file names inside of the folder that you specified. And then inside of the for loop, you can work with that information. That's kind of all that's happening here. And in my case, I am not going to need directory path or directory names because they're not relevant for me. All I care about are the file names of the images inside of that folder. So I'm going to ignore the first 2 arguments that are going to be returned. But let's have a look at this in code. So let's start by creating the for loop. So let's call this information for now in walk, and walk only needs 1 argument, and that's a path. And now in here, let's just print information. And let's just see what's going to happen. And actually, if from my player class, I can copy all of this and run the function by itself. So I want to import folder, and the file path is this, and let's go with run. And let's see what we get. And there in the bottom, you can see we have gotten a tuple with the name of a folder. So the information we already have, so we don't need it. After that, we will get what's called directory paths, which is just a fancy name for folders inside of that folder. And this folder doesn't have any subfolders, so this one is also relevant to us. Now, the important information now is that these are all the actual files inside of that folder. And this is what we actually care about. So this is what I am going to focus on. So when we create the for loop, let me get rid of all of this. There are 3 bits of information. Let's call it 1, 2, and 3. And only 3 is the important one. So this is going to be the image file, let's call it. And for 1 and 2, so the directory name, I'm just going to put an underscore. And for 2, I'm going to put 2 underscores. So I indicate that I don't care about what's being returned here. And with that, I get access to all of my image files. But now I have to figure out what I actually want to do with them. And what I want to do with them is I want to import them and put them into a surface. And then I want to put all of these surfaces into one list and return this entire list of surfaces at the end of the function. And this could actually be a really good exercise for you. Try to do all of that and see how far you get. All right, so the first one we are going to need is we need a list. And I call this one surface list. And this is literally just an empty list. Now, next up, there are 2 important things for the next step. And this is all about this image file. And as a matter of fact, I should have named this better, because this is image files. And essentially what we are getting back here is a list with strings. So we're getting a list with the name of each file. And for now, I want to cycle through this list. So for, let's call it image in image files. And that way, each of these images is going to be the name of the image we want to target. And that I can use to create a full path. And the full path is just going to be my path that I already have, then plus a slash, and then plus the image. And that way we have the entire path from our code to our image. And once we have that information, we can just use, let's create another variable that I called image surface. And now we can just use pygame.image.load and pass in the full path. And as always, we need convert alpha to make this work properly. And then once we have that, I just want to get my surface list.append and then get my image surface. Oh, and a really important thing, we have to import Pygame. And now we are almost done. The last thing we need is to return the surface list. And that way we should be good to go. This is all we needed to cycle through any folder and import all of the images. Now, an important thing to remember here is that you really have to make sure that inside of each folder, you only have image files, so PNG or JPEG. If you have literally anything else, Pygame will still try to import it and put it into a surface. And for anything that's not an image, you are going to get an error. So you either want to be careful here, or you want to create some extra checks. It's really up to you. In my case, I'm not going to worry too much about it. But all right, so with that, we have our basic setup. Now I can go back to my player, and now this function here should be working just fine. And let's actually run this function here at the beginning of our player method. So self.import character assets. And now in the main file, let's try this, and we don't get an error message. That's a good sign. So with that, we have all the images that we are going to need in a file format that we can access. However, we still can't see it because all we are doing in our player, we use these 2 lines here to create a red rectangle that, well, looks kind of boring. So I have to use all of these animations and actually play them. And for that, we are going to need a couple more arguments. And that is going to bring us to a whole new topic, and that is animations in Pygame. And I have actually created a whole separate video on this ages ago, and I'm going to use the same logic here so you don't have to watch it. But in the most basic sense, all we are really going to do is that we are going to change self.image very, very fast. So for example, if our player is idling, we are picking one frame of it every few milliseconds and assigning that to self.image. And that's literally all we are going to do. It's not that complicated when it gets down to it. So, well, let's go through it step by step. So here I'm back in the code, and there are two more attributes that I do want to include. The first one is self.frameIndex. And by default, this is going to be 0. And this is going to be the number we use later on to pick one of these animation frames. So once we have jump, for example, we are going to pick one of the frames in here. And besides that, the other attribute is animation_speed. And I set mine to 0.15. And well, this tells us how fast our animation is going to update. And now once I have that, I can get rid of self.image.fill and replace my pygame.surface with a specific animation, or for now, a specific frame from this self.animations. So I want to get my self.animations, and for now, target one animation in here. And I went with idle. So this will give us a list of different surfaces. And I want to pick the first one of it. So self.frameIndex. And that way, we should now be seeing a pirate once we run this game. Let's try. And there we can see our main character. It doesn't animate at all right now, but well, it is working reasonably well. So we can see something. Cool. So we know this is working. But now, obviously, this doesn't look particularly great because we have no animations whatsoever. So this is going to be what we will start working on right now. And inside of my player class, I want to create another method. And let me put it right below importing the character assets. And I've called this one self.animate. And in here, for now, we have a little bit of a problem because to play the different kinds of animations, so if I want to play idle, run, jump, or fall, I first need to know what I actually have to play. So I have to know if the player is running, jumping, falling, or idling. And right now, I don't really know any of that. And this is something we'll address in just a second, but for now, I want to get a basic animation. So what I want to do for now is just to cycle through the run animation. That should be the one you can see the best. So inside of animate, I first want to simplify things a bit. So I'm going to create another variable that I just call animation. And all I want to do in here is get my self.animations, and for now, pick run. So later on in here, we are not going to pick a specific key from this dictionary. Instead, we're going to make this more dynamic. But for now, this one should be fine. And now the first thing I have to do is to loop over the frame index. And really all that means is I want to get my self.frameIndex and that plus equal self.animationSpeed. So if I go up a tiny bit, I want to get this number here and add the animation speed towards it. That's literally all that's happening here. And then once I have that, I want to check if my self.frameIndex is greater or equal to the length of my animation, this one. Then I want to set self.frameIndex back to 0. So what does that mean? Let me go up a tiny bit again. And we are looking right now at these two numbers here. And on every frame of our game, we're going to add 0.15 towards this frame index. And essentially what I want to do, and let me actually illustrate this. So we start with 0, then we have 0.15, then we have 0.3, 0.45, 0.6, 0.75, then 0.9, And at some point we get, let me put it in here, 1.05. And this is going to keep on going for basically forever. And now the problem is, inside of each of these lists, we only have a limited amount of surfaces. And essentially what I want to do is that if I am on 0, and for any number that comes after 0, I always want to pick the element 0. However, once we are reaching, let me use a different color for that. Once we reach the number 1, I want to pick the item with the index 1 from the list. And this way I can control the speed of the animation quite well. Now, the problem we have here is that by itself, this number would keep on increasing. So after about a second, we would already be at possibly something like 10. And there are not 10 elements inside of run. So we have to make sure once this number is being greater than the amount of items inside of this list here, we want to set this back to 0. And that way we get a loopable animation that works really, really well. So I hope that makes sense. And well, that's all we have done here. And now once we have that, all we have to do is to target self.image and set this to the animation, and from there pick self.frame_index. However, this by itself would not work, because to pick an item from this list, we need an integer. And this right now is a double. So we have to convert it to an integer. And now this should be working. So let's try to call it and see what happens. So self.animate. And let me run the code. And there you can see the animation. Obviously, it still doesn't work. And also we get a bit of a problem with the collisions. We're going to fix that in just a bit. And also if I move to the right, okay, it still works mostly well. But there are some minor problems with the collisions. But now we have our basic animation. So now we have a basic animation. And we can also play different kinds of animation. So in here, if I change this run to idle and run this code again, I can see that our player is playing a different animation. So this is already working reasonably well. And the main problem we have now is to figure out what the status of the player is. So is the player on the bottom? Is the player running? Is the player against the wall? Is the player falling? All of that kind of stuff is what we have to figure out now. And once we have that status, we can play different animations. So we have to think about how to get different states of the player. And there are 4 different states that we have to figure out. We have to figure out jump, fall, run, and idle. And to figure all of this out, the direction of the player is incredibly useful, because we can use the X and the Y information inside of the vector to tell what the player is doing. And let me actually jump into the code and explain how this is useful. So here we are back in the code, and I want to have a look at the player, and let me minimize all of this. And I want to create a new method. Let's put it below get input. And this one is going to be get status. Doesn't need any arguments. And in here, I want to figure out what the player is doing. So is the player jumping, running, falling, or idling? And for that, this self.direction is really useful. So for example, if the direction.y is negative, we know the player is going upwards. And the only reason for the player to go upwards is if the player is jumping. So if the direction.y is negative, we know the player is jumping. And by the same logic, if the direction is greater than 0, we know the player is falling. And if direction.y is 0, then we know the player is standing on the floor. And once we have that, we know we can check for X to know if the player is running left or right. And well, that's all we really need here. So let me actually implement this. The first thing I want to figure out is the y-axis. So if self.direction.y is smaller than 0. So our player is going upwards. And if that is the case, I want to create self.status. And the status here would then be jump. And actually, let me put in the init method, let's call it player status. And here I want to create player.status, and by default this should be idle. So we already know when the player is being initiated that we have one state, so we don't get an error. So now we know if the y direction is negative, we are jumping. Now we need an else statement that self.direction.y is greater than 0. And if that is the case, I want to put my self.status to fall. Because if the direction is greater than 0, we know the player is going downwards. And the only reason for the player to go downwards is to fall. So this would also be an easy status. Now, if neither of these cases is true, so if direction.y is equal to 0, we know the player is standing. So I can add an else statement in here. And now I want to figure out if the player is running or idling. And this could be a really good exercise for you. Try to think how to approach a direction.x to figure out if the player is running or not. All right, so all we really need in here is if self.direction.x is different from 0. Because if we are running, we have a moving left or right. And if either of these is the case, we are going to run. So if direction.x is different from 0, self.status is going to be run. And then finally, if none of these are the case, I want self.status is equal to idle. And that way, I already have my basic status. There is one problem, but I'm going to show what that does in a second. But first of all, before I run self.animate, I want to get self.getStatus. And now, in my animate function, I can replace this idle with self.status. And now we should be getting different animations. At least kind of. So when I jump and fall, this is working. However, if I'm on the floor, we get something very, very weird. And well, so let me explain what the problem is. Essentially, if I go to level and to the vertical movement, the problem we have happens essentially in all of these lines here. And basically what the problem is, that if our player is standing on the floor, so let me actually draw this. So here we have our player, and here we have the floor. Now, every time we are applying this movement collision, we are moving the player down by the amount of gravity. So in my case, I think this was 0.8. And after we have done that, we are checking if the player is overlapping with something. And if that is the case, we are moving the player back to exactly on top of this tile. So that way it looks like the player is on top of the tile all the time, but that's not really the case. Instead, what is actually happening is that the player is being moved on top of this on every single frame once it overlaps. And this is working reasonably well. The one problem with this approach, however, is that our self.direction.y, so this number here, is never going to be just 0. It is always going to be either 0 or positive 0.8. And as a consequence, in our player, if we are checking for this number here, sometimes it is 0, sometimes it is greater than 0, even though we are on the floor. So Pygame plays either fall or run or idle really fast between each other, which then ends up looking very, very silly. So how could we address this? And well, the answer is actually really simple here. All we have to do is change this 0 to a 1, or more precisely, any number that is greater than this gravity here. So that way, we are only going to play the fall animation if our player falls at a certain speed. And that way, we are fixing all of this. So now our player looks much better and all the animations play pretty well. So this is already looking quite good. Cool. But now we have a couple more problems. The first one is that our player always looks to the right. It never looks to the left. And also, if you look a bit more closely at the animation, it doesn't actually work out perfectly because our player is, well, it looks like it's jumping for a tiny bit. And that's not how the animation is supposed to be played. The feet are always supposed to touch the floor. I'm going to explain in a bit how to fix that. But first of all, let's work on the direction. And for the direction, I want to create another attribute. And let's call this self.facing right. That's the default. So by default, this is going to be true. So if this is true, I want my player to face to the right, and if it is false, I want the player to face to the left. So now I have to figure out how can I change this attribute here. And well, it's actually quite easy. When I run my get.input and I press either left or right, then I want to change these values. So self.facing right, if I press right, is true. And if I press left, then it's going to be false. So we are essentially changing this value if the player is pressing left or right. That's all we needed. And now inside of our animate function, so this one here, I can add another if statement. So if self.facing right, if that is the case, self.image should just be what it used to be. However, if that is not the case, I want to add an else statement. And in here, I want to flip the image. And let me reorganize this code a tiny bit. So let me copy all of this and place it right on top of the if statement. So right now, we're just creating a local variable inside of this method. And if we are facing right, we're just assigning this image to self.image. So no change so far. However, if we are facing to the left, I want to create another variable that I called flipped image. And to flip an image, all we need is pygame.transform.flip. And in here, we need a surface, so in my case image. And then we need two Boolean statements. The first one is if you want to flip this image horizontally, the second one if you want to flip it vertically. And in my case, this should be true and false. So this true here is for the flip in the x-axis, and this value here is for the flip in the y-axis. And I only want to flip my surface in the x-axis. I don't want to rotate it around the vertical axis. And now once I have that, I want to get my self.image is equal to the flipped image. So that should be all we needed. Let's try this. And now if I press left, this is working pretty well. Cool. So now our player is actually moving in the right direction. Or well, it's facing in the right direction. But this is then already looking so much better. So with that, we have our basic animations. However, they don't work as well as they should. And this is something I've shown earlier. So for example, if our player is just idling, it looks like it's jumping a tiny bit. So the feet are slightly lifting off the floor. And a similar thing you can see for basically all of the animations. And this is not intended in the animation. That's a problem in our code. And the problem here is that each of the surfaces has a slightly different dimension. So each image inside of the idle frames has a slightly different height. But our rectangle is always the same size, and we also always have the same origin point. And since Pygame always puts the surface on the top left of the rectangle, if the surface is too small for the rectangle, it looks like the surface is floating a tiny bit. So to fix this, we have to do two different things. Number one, we have to figure out what the status of the player is in terms of what the player is colliding with. So is the player on the ground, on the left or right wall, or on a ceiling? And once we have that information, we want to get a new rectangle and place the origin point of that rectangle to wherever the collision point happens to be. So let's go back into the code and let's have a look at this. So I first want to go back to my player, and first of all, I want to add a few more status information. I want to have an attribute with self.onGround. That is false by default. Then I want self.onCeiling. Then self.onLeft, which is false, and self.onRight, which is also false. So this is the information I need to place the rectangle properly after I've animated all of this. So now we have to figure out how to get these 4 bits of information. And they all need slightly different approaches. So let's go through this step by step, and let's start with the easier one. self.onGround and self.onCeiling. Because all we really need to figure out is in our level, we already have the vertical movement open. If this condition here is true, we know the player is on the floor. And if this condition here is true, we know the player is on the ceiling. So all I need to do here is player.onGround is equal to true. And for the else statement, player.onCeiling is going to be true here. However, we have to add a bit more, and let me explain why. Let's say for this line here, after our player is touching the floor, we set onGround to true. But the problem now is if our player is jumping, this onGround is still going to be true, even though we know the player is in the air. So we have no way to switch off onGround again. And for that, we have to add another few if statements. And I want to check if player.onGround is equal to true. And now I want to check if the player is jumping or falling. So if my player is on the ground and player.direction.y is smaller than 0, or player.direction.y is greater than 1. And if all of that evaluates to true, player.onGround is going to be false. So really all we're doing in here is we are checking once the player is on the floor and the player is jumping or falling, then the player cannot be on the floor anymore. And then we can do the same thing for onCeiling. So if player onCeiling, and now we have to add another condition. And in here, obviously, if the player is on a ceiling, he can't jump anymore. So we don't have to check if direction.y is below 0. However, we do want to check if the player starts falling again. So really, all I have to check in here is if player.direction.y is greater than 0. And if that is the case, I want to get my player onCeiling and set this to false. And that way we should cover pretty much all of the onGround and onCeiling. So now we can use that information back in our player to set the animation properly. So we have to effectively add a whole nother section that I called set the rectangle. And in here for now, I just want to check if self.onGround. If that is the case, I want to create a new self.rectangle. And this is going to be self.image.getRect. And in here for now, I just want to set the mid bottom. And where that is going to be is self.rect.mid bottom as well. And if that is not the case, and instead we are self.onCeiling, then self.rect. Let me copy the entire statement before. Is going to be self.midtop is going to be the mid-top of the previous rectangle. And it's probably a good idea to have another else statement in here, just in case something goes wrong. And well, all I want to do in here is to get my new rectangle is going to be at the center of my old rectangle. And now we can try to run all of this. And this is already working. So now we can see the animation looks significantly better because our player isn't levitating on the floor anymore. And well, we can still jump around. And here you can see kind of a small problem that our player sometimes jumps up on the ceiling. It's kind of hard to replicate. Can I get this? No, okay. It's very situational. But I'm going to explain the bug you have just seen in a bit more detail. But there's one more thing I do want to work on. Because right now, our player can jump on in the air, which is not the point of the game. So I want to give some extra code that the player can only jump if he is on the floor. And this could be a really good exercise for you. Try to add some code that the player can only jump if he or she is on the floor. All right, so if I go back to my player and I minimize the animate function and the init function, I want to check at my get input. And in here, I have a check that if I press the space button, and literally all I have to do is I want to check and self.onGround. So the player is only going to jump if we are pressing space and if the player is on the ground. And only if both of those are true, the player is going to jump. So now let's try this again. And now, even though I keep on pressing space, the player only jumps once he hits the ground. And well, this is then feeling much more natural. And we are making some really good progress to a proper 2D platformer. Now, actually, if I run this again, maybe I can make it happen. No, it's kind of difficult to work out. There we go. So now you have seen a small bug in our code. And let me explain why that happened. And let me go to a player to actually explain this properly. So we need the animate function, this one. So the problem we have right now is that whenever we are moving the player around, we are also getting a new rectangle, at least whenever we are on the ground. But now the problem is, for the idle animation, some images are wider than others. So we would get a rectangle with a different dimension on every single cycle of our game loop. And for most situations, this would be fine. However, if we are touching a wall and updating our surface, there is a small chance now that there's an overlap, because we have a wider surface that creates a wider rectangle. And then Pygame gets confused and thinks that the player is overlapping on the bottom. And as a consequence, it places the player on top of the tile, which then makes the game look kind of buggy. And the way to fix this is by checking if we are colliding with a left or right wall. And I already have the attributes, that's on left and on right. Those to check if we are colliding with a wall on the left or on the right. But getting that information is slightly different compared to the vertical ones. So let me go through it step by step. So here I'm back in my player and I want to go to my level. And here we already have our player on ground and player on ceiling. But I want to look at the horizontal movement. And in here we have to start in a similar way compared to our vertical movement. So I have to check if I'm moving left and colliding. Then I want to check self.on left to true. And if I'm moving to the right and colliding, I want to get my player.on right and set that one to true. So now we can switch on the attributes if the player is colliding with a left or right wall. However, the problem now is turning these attributes off or to set them to false is kind of more complicated. So let me explain the problem here. Let's say our player is moving to the right and then is colliding with an obstacle. So we set player on right to true. But now the player keeps on pressing right and jumps. In this case, the player is not colliding with a wall anymore, but player.onRight is still set to be true. As a consequence, we can't really use our direction.x to figure out if the player stopped colliding with a wall, because it might happen that the player just keeps on pressing to the right and then jumps over a wall. So we have to figure out something else. And here's how I fix that. Every time our player is colliding with a horizontal wall, we are getting the x position of the player. And then to turn off player on left or player on right, we are checking if we are exceeding this point either positively or negatively. And that way we can tell if we are moving past the point of collision. So you kind of have to think about the solution here a little bit, but I hope it makes sense. But let's implement all of this. Here I'm back in the level. And the first thing I want to do is to create a new attribute right at the top. And this is going to be self.currentX. And by default, let's put it at 0. It really doesn't matter what it is. And now, if we are colliding with a left or right wall, I want to get my self.currentX and set it to player.rect.left in this case. And if we are colliding with a right wall, this should be the right side. So this way we can tell the x position of where the collision has occurred. and we are storing that information in self.currentX. And now let's say, for example, for the right side of the player. So this one here. So here is the player. And let's say here we have a wall on the right side. Now, as soon as there's a collision, we are checking this point here. Or well, rather, we are checking the entire yellow line. And really, all I want to check is that if the right side of the player is further than that point, and if that is the case, I can safely assume that the player is not touching this right wall here anymore. And this is what this current X is for. We are really just checking what the collision point is. Again, the name probably isn't perfect, but I guess it's good enough. So with that, I can add a couple of if statements like I've done here to figure out when to set on right and on left back to false. And let's start with the left side. So if player on left, and now we need a larger if statement. So what I want to check is player.rect.left is smaller than self.currentX. And if I have that information, I know the player has exceeded the obstacle, so I know it's not touching that obstacle anymore. And if that is the case, I can set my player.onLeft back to false. However, there's one more situation, that if we are touching a wall on the left, it's perfectly possible that we are just moving to the right, and that way would also stop touching the left wall. So what I also have to check is an OR statement in here, that player.direction.x is greater or equal to 0. So that way, if we are touching a wall and stop moving to the left or moving to the right, we know that we are not touching the left wall anymore. And if that's the case, we can set on left to false. And now, same thing if player.onRight. And now we can basically copy all of this and make some changes. So first of all, this is player.onRight and is greater than self.currentX. And this one should be smaller or equal than 0. So we are moving left or we're not moving altogether. And if that is the case, player.onRight is equal to false. And now with that, we have all the basic information we need. But first of all, let's run this game and see if this is working. Okay, for now, we haven't implemented the new rectangles yet. The main thing I'm looking for is that we don't get an error message. And that looks pretty good. So cool, this is working for now. So that way we know that, let me go to my player, we can get these information reliably. So we know what the player is colliding with. So now we have to use all of that in here to actually set the rectangle. Or more precisely, to set the origin of the rectangle. And this is going to be quite a few different if statements. So let me go through them one by one. First of all, if the player is on the ground is one thing, but I also want to check if let's start with on right. So if the player is on the ground and touching something on the right. If that is the case, I want to set the bottom right of the player. And the position should be where the previous bottom right rectangle was. And now we have to do the same thing for the ground and the left side. So on left. And well, now I can just copy all of this statement here and change bottom right to bottom left. And same thing with bottom left here. So now we have the situation where the player is on the ground and colliding with the right wall. He is on the ground colliding with the left wall. But I also want to have the situation where the player is only on the ground and not on anything else. And well, if that's the case, I just want to get my mid bottom again, the same thing I had in the beginning. And now that way, we are covering all the possible scenarios for the player being on the ground. Now we have to do the same thing for on ceiling. And well, in my case, I am going to copy all of this so I don't have to type too much. So this has to be an elif, and now we have to change a few things. This should be on ceiling, and we are on the right, and now we don't want to check for the bottom right, we want to check for the top right. And same thing with the previous rectangle, top right. Then we have to do the same thing for the left side. So this would now be the top left and the top left here as well. And then finally, just for the plane on ceiling, now I would just look at the mid top and the mid top for the previous rectangle. And that way we have covered the possible collisions. Now let's try all of this and see if this is working. And there we go. Now the bug doesn't seem to appear anymore. And this we can just keep on moving around. And now the animations actually look quite a bit better. So, well, this is then helping our player animations quite substantially. So, all right, we are making some really good progress. And all right, so with that, we have covered the entire player. I know the final part did get a bit more complex, so I hope it made sense. If you are completely confused, just let me know in the comments, I guess. But now that we have the player, the last thing we have to do for this tutorial is to add the particle effects. And in here, we have 3 different kinds of particles. We have run particles, we have jump particles, and we have fall particles. And the run particles are very easy to get. We are basically doing the same animation we have done for the player, except with different sprites. However, for the jump and the fall, we have to create a slightly different kind of animation. But let's do this step by step, and let's start with the run animation. And let's go straight into the code, and let's have a look at this. Here I'm back in the code, and I want to have a look at my player. And let me minimize all of the methods we had so far, so there's a bit more space. And now the first thing that I want to do is to import the dust animation frames, the ones for the run particles. And let's call this one import dust run particles. And in here, I want to create a new attribute, and let's call it dust run particles. And really all I have to do in here is to get my import folder function again, and now I have to pass in the path. And the path is going to be this, and we want to look at the run particles. And now in the init method, let's call it right at the beginning. I think it makes the most sense in there. So import dust run particles. And let's try if this is working. We don't get an error. That looks pretty good. So now we have the list of images that we need. Next up, we have to figure out how to animate through them. And basically what we are going to do. Let me go to the animation part. So effectively what we are going to do is we are going to copy this stuff here, but with 2 differences. Number 1, we don't use the player animation. Instead, we use a dust animation. So the one we have just imported. And number 2, we are not going to put all of this on self.image. Instead, we are going to pass the display surface into our player and then blitz straight onto the display surface. And that is because the dust particles are not supposed to be on the player, they are supposed to be on the actual background. But those differences in terms of code are actually fairly minor. So most of this logic is still going to apply. But let me go through this one by one. So let me minimize this. And now let me actually put this a bit further down. And let's create a new section here with a comment, and let's call it dust particles. That's probably a bit easier to read. And now essentially I'm going to copy those 2 attributes here. So we have our frame index and our animation speed. And let's call these 2 the dust frame index and the dust animation speed. And this would allow us to create a basic animation. But so far, we don't have anywhere to put this animation on. So what I want to have is I want to get this screen display surface available in my player. And well, to achieve that, I have to create a new parameter. Let's call it surface. And this surface is going to be self.display surface, ideally spelling this correctly. And this is going to be surface. And now when I create this player inside of my level class and inside of setup level and down here, I also want to pass in my display surface. And I already have my display surface. It's this one here. So all I have to pass in here is self.display surface. And that way my player is going to have the display surface available. And just to make sure all of this is working, let's run the code. It starts properly, so this seems to be working just fine. So now I have all the basic parts I need to create the basic animation. So I can close or minimize all of this. And let's say right below our animate function, I want to create dust animation. Actually, let's call it run dust animation. And in here, we are going to add the code for the animation. However, we first want to check if we even want to play the animation. Because if our player is jumping or falling or idling, there shouldn't be the run animation dust particles. So I first want to check if self.status is equal to run. And I guess just to be sure, and self.onGround, not particularly necessary, but I guess it can't hurt. And if that is the case, I want to get my self.dust frame index, that one. And towards that, I want to get my self.dust frame dust animation speed, that one. And now with that, if self.dust frame index is greater or equal to the length of self.dust run particles, then I want to set self.dust frame index back to 0. So this so far is exactly the same thing we have done here, except with different numbers. And we are going to continue doing the same thing, because now I want to set it dust. And that is going to be self.dust run particles. And in here, we're going to get the integer of self.dust frame index. So if I open the animate function again, this is the equivalent of this line here. So far, literally nothing new. And next up, we have to again figure out if the player is moving to the left or to the right, because that informs if the dust particles are left or right. And well, we have that information. If self.facing right, so for players moving to the right, I want to get my self.display surface, and now I want to blit it in a certain position. So I want to get my dust particle, and now I have to figure out the position. And actually, let me place this in its own separate variable, so it's a bit easier to read. And in here, I need an X and a Y variable. And in here, really, all I want to get is self.rect.bottom left. So if our player is moving to the right, I want to spawn the dust particles in the bottom left of the player and then draw them on the display surface. Should be quite straightforward. And let's actually run all of this and see if this is working. So after animate, I also want self.run dust animation. And if I run this, we are getting an error because this double colon shouldn't be there. And now let's run the code. And if I move to the right, we are getting some dust particles, although not in the right position. So they need some kind of offset, but if I move to the left, nothing's going to happen. So we are almost there. So let me go back to my player. And the problem right now is that the bottom left is too far down. So I want to give this bottom left an offset. And for that, vectors are incredibly useful, because literally all I have to do is to get the bottom left of the rectangle and subtract from that pygame.math.vector2. And in here, I can specify x and y variables and subtract that from the bottom left. So just to explain why this is useful, that this bottom left has an x and a y attribute. And if you used anything other than a vector, you would have to specifically target the bottom and the left of this position. But if you have a vector, you can just subtract the entire vector, and Pygame is automatically subtracting the correct x and correct y values, which is making our life significantly easier. And now in here, you just have to figure out what values are correct, or what values make this look good. And in my case, I went with 6 and 10. And I got those from just experimenting. There's no universal value here. But now if I run, we are getting some... Okay, that was terrible. Let's try this again. Now if I run to the right, we are getting properly looking dust particles. So this is working pretty good. So now we have figured out if the player is moving to the right. Next up, we have to figure out the left side. And this could be a really good exercise for you. Add the code that if the player is moving to the left, we also get dust particles. And again, this is going to be very similar compared to the animate function that we created earlier. Alright, so first of all, I need an else statement. So we check if we are moving to the left. And then again, I want to get a position for my dust particles. And now I don't want the bottom left, instead I want the bottom right. And for these two values here, for the offset, we are going to check how this is going to look in just a second. Next up, we have to flip this dust particle. And let's call this flipped dust particle. And in here, we need pygame.transform.flip. And now I want my dust particle. I want true and false. And again, this Boolean statement here is for the horizontal flip. This one is for the vertical flip. And we don't want to flip anything in the vertical axis. And then finally, I want to get my self.displaySurface.blit. This is my flipped dust particle and my position. And well, that's all we needed. Let's try this now. And if I move right and if I move left, this works pretty good. And I think the position here actually works quite well. So, okay, down there I have a bit more space. And yeah, I think with that we have a pretty good animation. So with that, we have our basic run particles. So that's going to be the first particle effect, but there are two more. One is for landing and one is for jumping. And those two are going to work differently compared to the run animation. And the major reason why it is different is that the run animation is supposed to be looped. So if it goes to the end, we want to go back to the start. However, for the jump and for the land animation, we only want to play them once. So after we have finished all of our animation frames, we want to end the animation. So the logic for the animation has to be slightly different. And there's another issue we have to work on, that for the run animation, we want it to be in the same position as the player with a slight offset, so it's moving along with the player. However, the land and the jump animation are supposed to be static. And really all that means in practice is that if the player is jumping, we want the jump particles to stay on the ground. They're not supposed to follow the player. So there are a couple of things we do have to address. And I approached this by creating a whole new class that I called particle effects. And this one takes care of the entire logic. And I think it's going to be best if I explain this while I actually create it. So let's jump back into the code and let's have a look at this. So here I'm back in my main file and I want to create a new file. And let's call it particles.py. And from support, I want to import folder because we are going to need it. And now I just want to create a class, let's call it particle effect. And this one is again going to be a sprite. So pygame.sprite.sprite. And in here, we are going to need an init method. And in here, the parameters we need are going to be self, the position, and the type of animation we want. And let me spell all of this properly. Now we are still going to create an animation. So I need my frame index. By default, this is 0, and self.animation speed. And let's set this one to 0.5. And again here, this number, just choose whatever you think looks good. There's no objectively right answer to this. And with that covered, we have to figure out where we get our images. And for that, I want to check the type. So if the type is going to be, let's call it jump, then I want to create an attribute that's called self.frames. And I want to get my import folder. And in there, the file path is this one. So we still have the same dust particles folder, but now the subfolder is jump. And in there, we have a couple of frames. And then along with that, I can copy all of this. And let's call this one land. And in here, also the land folder. And with that, we have all the information we need to set up a basic frame. So self.image is going to be self.frames and self.frame index. And then self.rect is going to be self.image, spelled correctly, .get rect. And then here, I just put the center at the position where I want it to be. And this is then all we needed for the basic setup. And with that, we are going to need two methods. The first one is the animate method, and the second one is going to be the update method. And really important here, the update method is also going to need an x-shift variable, because if we are scrolling through the screen, this one here is also supposed to move with the level, so it needs it as well. And well, in here, all we need is self.animate and self.rect.x plus equal x-shift. So all we are going to need now is the basic logic of our animation. And well, we need frame.index plus equals self.animation speed. Then if self.frame index is greater or equal than the length of self.frames. And if that is the case, in the past we set self.frame index back to 0. But in this case, we don't want to do that, because after the frames are run out, we want to get rid of all of this. So instead, what I want to do is self.kill. And this way, we are destroying the sprite after this animation has run out. But if that is not the case, so an else statement, so if we are still inside the length of our frames, then self.image is going to be self.frames, the integer of self.frame index. And that way, we have an animation that is going to run only for the duration of the frames. If we are running out of frames, we are destroying the sprite. So this is all we are going to need for the particle effect. So now we have two more problems. The first one is we have to figure out where to play it. So what's the position of this particle effect? And the second one is we have to figure out when to play it. So we know when the player is jumping, or how do we know when the player is landing? And well, the easier part is to figure out when the player is jumping. Because we know the player is jumping when, let me go to my player, and let me go to get input. And in here, we know the player is jumping if the player presses the jump button. So that one is very easy. However, the problem is that to get the position, I have to create this particle inside of our level.py file. Because only in here can we use the world shift argument, which we couldn't do inside of our player. So both the landing and the jumping particle effect have to be inside of level. So let's create the entire thing in here. And let me first minimize all of the other methods, because this is going to be very hard to read otherwise. And let me put it right at the top. It doesn't really matter where you put it. And in here, I want to create a function that I call create jump particles. And this one's going to need self and a position. And if you're running this method, I want to create a new particle effect. And let's call it jump particle sprite. And this one is just going to be the particle effect. So the one we have created in here. And to use it, we first have to import it. So from particles, import particle effect. And for this one, we need a position and a type. And let me just copy them over so we can work with this a bit more easily. And the type is the easier part because I just called this jump. So the same jump we create here for the type. But now we are going to need a position. And the position we are going to get from the argument that's going to be passed in here. You're going to see in a second how that is going to work. So now we have a sprite, and I want to create a whole new group for that sprite. So let me create a new section in the init method, and let's call it dust. Let's keep it at dust. And then here, self.dust sprite. And this is going to be pygame.sprite.group single. Because I only ever want to have one animation of the dust particles, because we have a jumping or landing. We can't really do both at the same time. And now all I want to do is to get my self.dust sprite and add the jump particle sprite to it. And then in the run method of the level, let's put it under the player. I want to add my dust particles. And in here, self.dustSprite.update. And again, we need self.worldShift. And then self.dustSprite.draw self.displaySurface. The exact same thing we have done earlier for the tiles. So now the one thing we have to figure out is when to call this method here. And well, we need to get this method inside of our player so that we can call it inside of this part here. And well, that's quite easily done. So in setup level, besides the display surface, I also want to pass in self.createJumpParticles. And make sure here that you don't call this method. So these brackets here should not be there. And now inside of the player, we get another parameter. And that is, let's call it createJumpParticles. And again, do not add the brackets in here. And now in the init method, we can create this. Let's put it here. So self.createJumpParticles is going to be self.createJumpParticles. And now what we can do inside of this if statement, once we are jumping, I also want to call self.createJumpParticles. And this one now is going to need a position. And the position, well, is going to be fairly easy to get because all I want is self.rect.midBottom. And well, that should be all. Let's try this now. And we are getting an error. Let's have a look. Oh, and this should not be having a self at the beginning. So now let's try this again. And there we go. And now if I press jump, we are getting another error. So let's have a look at this. And in here, you can see it in the error message already, that Pygame.surface object has no attribute getRect, but the rect is a capital R. So that's quite an obvious error. So back in the particles, this one here should not be capitalized. And third time's the charm. Okay, or not. And I forgot, now we have the attribute error, no sprite G. And what that means is we need super.init. And now let's try this again. And there we go. Now we have our floor particles. Except now the problem is that these particles are not exactly in the right position and they are in front of the level. So two things we have to address. The first one, well, the second one is very easy. Because what I want to do is to put all of this behind the tiles, like this. And now if I run this, Now this looks much better. And now we get some nice particles. So this is looking pretty good. And now I want to give the particles an offset. And this offset has to change depending on if the player is facing left or right. So let me demonstrate. And let me jump here. So if we are facing to the right and we are jumping, the dust particles are a little bit too far to the right. But if I'm facing left, the dust particles are a bit too far to the left. So they need a different offset depending on if we are looking left or right. And well, this we can address quite easily. So back in the level, and when I create the jump particles here. And really all I want to do is to check if the player is facing left or right. So if player.sprite.facing right, if that is the case, I want the position to have an offset of a certain vector. So pygame.math.vector2. And in my case, I went with 10 and 5. And again, choose whatever value looks good in here. There's no objective answer. And then we can do the same thing for the other case. So else, so we are facing left. Then I want to offset my position. And in here, I want to add plus equals and then -5. And this is all we needed, I think. So let's try this now. And we are getting an error. So let's have a look at level. And this should be self.player. There we go. And now the jump particles are right below the player. And that does feel quite a bit more realistic. So, all right, with that, we are making some pretty good progress. Now, for the final part, we are going to need the landing particles. And those are a tiny bit more difficult to get. Because we have to figure out some code to understand when the player is landing. And this can't be done in a single line of code. So let me explain the logic of what we are going to do here. Inside of our level class, we are going to create 2 new methods. And the really important thing here is when we are calling these methods. The first method is going to check if the player is on the ground or not. And this method is going to run before the vertical movement of the player. So we know that before any collision happens, if the player is on the ground or not. And then we're going to run another method. And this one is going to check if the player was in the air before the collision happened. And if after the collision the player is on the ground, we know there was a landing. And if that is the case, we can call the landing sprite animation in the very similar way compared to the jump sprite animation. So let's create all of this, and that's going to be the last part of this tutorial. It's already a really long video. So here we are back in the code, and I want to go to my level. And then here, again, let's minimize all of this stuff, and we don't need any of this. And now I want to create one new method for now. And let's call this one getPlayerOnGround. It needs self and nothing else. And really, all I want to do in here is if self.player.sprite.onGround. And if that is the case, I want to create a new attribute. And I called this one PlayerOnGround. And this is going to be true. And in the init method, I want to create this attribute. So self.player.onGround. And let's say by default, this is going to be false. And if I go back to it, now if that is not the case, so else, then PlayerOnGround is going to be false. And this case here, if PlayerOnGround is false, we know the player is in the air. So this is the really important bit of information. Now this by itself might seem kind of pointless, but you're going to see in a second why that is useful. So now this method here, I want to call before we are calling our vertical movement collision. So before that, self.getPlayerOnGround. So before any vertical collision happened, I want to know if the player is in the ground or not. So that's the first step. But then the second step is, let's call this method create landing dust. And this one again needs self and nothing else. And now in here we have to check an if statement. And first of all, we want to check if the player is not on the ground. So if not, self.player on ground. So this attribute we created earlier. But now we're also going to check if self.player.sprite.onGround is true. So I just leave it like this. And if that is the case, I can create a fall dust particle. And this is just going to be particle effect. And in here we need self.player.sprite.rect.mid.bottom. And then the type of animation is going to be landing, I think I called it. Let's double check. And yeah, land. And then self.dustSprite.add fall dust particle. And now this method here, let me actually copy it. This method has to be called after the vertical movement collision. So self.createLandParticle. And now with this logic, we basically have two storage variables for the status if the player is in the air or not. The first one is the player on ground. So let's say this is the first one. And then the second one we get from the vertical collision. So this is our second condition. And now really all we are going to check in create land dust is if these two conditions have differed after we have run the collision. And if there was a difference between these two, we know that the player has landing. So the player went from being in the air to being on the ground, which is, well, it's a landing. So that's the entire logic here. But there are a couple more things I would like to add. And the first one is another part of this if statement. And that is and not self.dust.sprites. So we only want to play all of this if there's no sprite inside of our group single. And the reason for that is there's a small chance that if we are landing, this animation might play multiple times, which would look, well, silly. So this kind of ensures that we are only going to play this animation once. And then besides that, just like we have done for create jump particles, I want to create a bit of an offset. So I need another if statement that if self.player.sprite.facing right, then I want to create an offset. And the offset is going to be pygame.math.vector2. And I went with 10 and 15. Again, numbers that just look good. And then I have an else statement. And let me just copy the offset here. And the offset here is just going to be -10. And now for the position, I can just minus the offset. And well, with that, we should be good to go. Let's try. And we are running the code and we're getting an error. So let's go through this. First of all, attribute error, level object has no attribute dust. So let's have a look at level. And the problem here is self.dust is wrong. This should be self.dust_sprite. And yeah, down here, it's the proper way. So that was one error. And we get another one. And here, again, reading the error messages is really useful. That module pygame.math has no attribute vector2. So I just made a typo. So let's go back to the level. And this is just a simple typo that I also copied. So now let's try all of this. And there we go. This is looking much better. So now I can run around and I get some really nice particle effects for all of this. And the entire thing works really well. Except now I suck at video games and we don't really have a dev state in this game. But well, that's not really the point of this tutorial. But that was basically it. So I hope that was helpful and I'll see you around.